interrupts at a time. So it can take 8 interrupts at a time. So and these interrupts will be transferred to this microprocessor by using this PIC. So PIC is nothing but it is a programmable interrupt controller. So which is connected to a microprocessor. So why we are connecting this PIC to this microprocessor? In order to make sure that every interrupt provided by these external peripherals are transferred to the microprocessor and handled, that means addressed by the microprocessor. So we are using a PIC in prior to this microprocessor in order to in order to make the microprocessor address the interrupts provided by the external peripheral. So this is what PIC do. So why is it need for PIC? Since we are having only these many pins for handling the interrupts within the microprocessors, which is not possible to handle n number of interrupts at a time. Okay, so it cannot it cannot take n number of interrupts at a time. So PIC having 8 interrupt lines, it will take 8 interrupts at a time and it will store those interrupts. It will transfer one by one to this microprocessor. So the PIC main task is to transfer the interrupts. It only transfers the interrupts to microprocessor unit. So it will not address any interrupt. It will not address any interrupt. It will not execute any interrupt. So no execution process will be carried out in PIC. Not execute. So it will not execute any of the interrupts, but it will take all the interrupts from all the devices connected and it will transfer each interrupt to the microprocessor based on priority. Okay, so it will prioritize those interrupts. So whatever the interrupts that are presented, so that will be taken by this PIC, programmable interrupt controller. So it will prioritize the interrupt. So based on the priority, it will transfer the interrupts to the microprocessor one by one. So on receiving an interrupt, the microprocessor will address that interrupt. So it will address the interrupt and it will send an interrupt acknowledgement after after addressing the interrupt. After executing the interrupt, it will send a interrupt acknowledgement through INTA pin. Okay, so it will send the interrupt acknowledgement. So that means the interrupt which came to this microprocessor has got addressed, has got executed, and that address is stored in interrupt service routine. So this will be indicated by interrupt acknowledgement to the this is carried out. So that is the need of the microprocessor. That is the need of connecting a PIC in prior to this microprocessor. So why we are connecting this PIC to this microprocessor? Respond. Are you there? Hello, are you there? So don't message me, please respond yes or no. So I have already turned on the camera, I can't see your messages. Please respond whether you are following or not. Are you there?
Yes, ma'am.
So am I in the meeting? Okay. Okay, so this is the need for programmable interrupt controller connecting to 8086 microprocessor. So what this PIC do is it will transfer the interrupts to the microprocessor unit. So this PIC contains 8 lines to take the interrupt. So it contains 8 lines to take the interrupts. Overall, if there are number of interrupts over the microprocessor unit, that means if the microprocessor is connected with several external devices, several external peripherals. So if the microprocessor is connected to several external peripherals, more than 8, so number of interrupts on this microprocessor unit will also get increased. So if it is greater than 8, if the interrupt count greater than 8, what shall we do? So we can simply cascade n number of PICs. Okay, so by simply cascading PICs, it can also accommodate 8. It can also accommodate 8
interrupts. So 8 interrupts. So every PIC can accommodate 8 interrupts. Based on our application, based on our requirement, we can cascade number of PICs in order to handle more number of interrupts. To handle more number of interrupts. Okay, so that means what case at this case when a more number of interrupts are there on this microprocessor unit through these external peripherals, we can simply cascade all the PIC controllers based on our application to handle more number of interrupts, so that they can handle more number of interrupts. So if 3 PIC controllers are cascaded, 8 plus 8 plus 8, 24 interrupts can be accommodated by these cascaded PIC controllers. Three PIC controllers are cascaded. If we connect 3 PIC controllers, we can handle 24 interrupts. Suppose if you cascade 8 PIC controllers, you can handle up to 64 number of interrupts. So this is the maximum limit of interrupts which can handle by using a PIC. Okay, so Intel 8259 is such a PIC which can be connected to 8086. So it is more compatible with 8259 is more compatible with 8085 and 8086 microprocessor. So since it is more compatible with the processor, we are now discussing about Intel 8259. So Intel 8259 is a PIC which is more compatible with the microprocessor. So this Intel 8259 is programmed either in level triggered manner or edge triggered manner. So I have explained this level triggering and edge triggering concepts in the last class. So once go through your notes if you have jot down the points. So this programmable controller, it can be either level triggered or edge triggered. So and the interrupt level also can be masked individually. So it can be masked the interrupt level individual bits. Okay, it can mask the interrupts on individual bits of interrupt request register. Okay, interrupt. So how can it mask the individual bit? Means it has an interrupt request register. So using that interrupt request register, it can be able to mask individual bits of interrupt request register. So it has an internal priority resolver. So I have said you that this PIC controller will take all the interrupts and it will transfer the interrupts one by one to the microprocessor based on priority. So how it will decide the priority of the interrupt? So based on the priority resolver, it internally contains a priority resolver. Okay, so this priority resolver is used to make the priority of the interrupt. So this is used to make the priority of interrupt. Okay, so this is how it will prioritize based on priority resolver. So whatever the priority resolver is there, this priority resolver is again of two types. So it has again the priority is based of the interrupts is made based on two categories. So one is fixed priority resolver and another one is rotating priority resolver. So the fixed priority resolver is nothing but it will be fixed with, so the priority resolver is fixed with a certain criteria. So based on that criteria only, the priority will be done in among the interrupts. So among the interrupts, the priority will be done based on this particular criteria. So only if the interrupts meet this criteria only, so they will get prioritized in the case of a fixed resolver. So in the case of a rotating priority resolver, so if you think about a priority resolver of this kind, rotating type of priority. Just a moment. Okay. Can you see?
Yes, ma'am.
Yeah. So if you consider this rotating type of priority resolver, so this priority resolver will be used to prioritize the interrupts based on the requirement. So it will be set with different types of criteria. So it will have different types of criteria. So based on the interrupt type, so it will set a criteria and it will fix the priority. So it will then fix the priority. So it has different criteria with in the case of rotating type of priority resolver. So in this type of priority resolver, based on the interrupt type, so whatever the interrupt that has been provided to the microprocessor with this external peripherals, so suppose if the interrupts are from input output units, so these are all one type of interrupts. So if the interrupts are from some memory units, so these are all one type of interrupts. So if the interrupts are from some external devices such as motor devices or LEDs or LCDs, so we can connect anything to the microprocessor. We can interface all these things to the microprocessor. So if at all it is from some thing like LED, so these are of one type of interrupts. So based on the device to from which the interrupt has been generated, so based on that we have different categories of interrupts. So we have different types of interrupts. So based on those things, this rotating priority resolver will set the priority. It will take everything into consideration and then it will set the priority for the interrupt. So that is what a rotating priority resolver do and what a fixed priority resolver do. So this is how the priority will be done. Priority will be provided in the case of 8259, and after prioritizing the interrupts, it will send the interrupts to the microprocessor unit. It will then send the interrupts to the microprocessor unit. So this is how the priority resolver will work. So next thing is this is PIC 8259. So let's now see the internal architecture of 8259 PIC. So this architecture of 8259 programmable interrupt controller. Okay, so 8259 programmable interrupt controller architecture. So let's see how this architecture will be. So it consists of a data bus buffer. So this is data bus buffer unit. So next it has a read and write logic. So this is read and write logic unit. So next it have a cascaded buffer and comparator. So these are the three units. So these will be connected to the different units through internal bus. Okay. So let's say this is the internal bus of so INT internal bus. So this is the internal bus. So next it has a control logic. So it has a control logic. So again it has in service register ISR. So next it has priority resolver. I have already said that. Next it has interrupt request register. Okay. So these are the three units again.
Okay. So this IRR consists of some interrupt lines. Okay. IR1, IR0 to IRN. So next, all these three are connected to some interrupt mask register. Okay, interrupt mask register. Sorry. Okay. So next, everything is connected to control logic. So everything is connected to control logic unit. So here you have a data bus unit, you have read and write logic unit, you have cascaded buffer and comparator. So through internal bus, these are all connected to a control logic unit. So which is connected to in service register. Okay. So it is connected to in service register and a internal interrupt request register. So this is an interrupt request register and this is your priority resolver. So these are all this is how the internal architecture of 8259 PIC will be. So this is how it looks like. So it consists of a data bus buffer. So data bus buffer, next one is read and write logic. It has a cascaded buffer and comparator unit. Next, control logic unit. So it has an in-service register. So next it has an interrupt request register. Next it has a priority resolver. Okay. So these are all present within the architecture of 8259 programmable interrupt controller. So what is the functioning of data bus? So let's see the functioning, the purpose of each and every unit one by one. Okay. So this is the architecture of 8259 programmable interrupt controller. Okay. So this PIC will never serve an interrupt. It will simply transfers the interrupt. Okay, it will simply transfers the interrupt, but it never serves the interrupt. It never serves. Okay, it will never addresses the or never serves the interrupt. Okay, so the function or the main task of a programmable interrupt controller is to just transfer the interrupts to the microprocessor unit. So it will just transfer the interrupts to the microprocessor unit. It will never ever serves an interrupt. Okay, so that is the functioning of this 8259 programmable interrupt controller. So here the architecture has different units, so that are combinedly functions. So all these will be function combinedly in order to increase the interrupt handling capability. So okay, so these all units will be collectively function. So they will be collectively function and to increase the, so why all these are functioning with a collaborative way? So to increase the handling interrupt handling capability. Okay, so to increase the interrupt handling capability, all these units of the PIC controller will be functioned collectively. So they will function combinedly in order to increase the interrupt handling capability. So first one is data bus buffer unit. So this data bus buffer unit have, so D0 to D7, 8 data lines. Okay, so 8259 programmable interrupt controller have a data bus buffer which is bidirectional. So this is a tri-stated bidirectional. Okay, so it is a tri-stated bidirectional data bus buffer. So it consists of 8 data lines. Okay, D0 to D7, it consists of total of 8 data lines. So these data lines are get interfaced with the internal bus of the processor. Internal bus of the processor. So these data lines are connected to D0 to D7 data lines of the data bus buffer are connected to internal bus of the processor. So the data bus buffer is a
tri-stated bidirectional buffer unit. So this is a tri-stated buffer unit which consists of 8 bits, D0 to D7, total of 8 bits. Okay, so it consists of a 8-bit data bus buffer. So it is interfaced with the internal bus of the processor. Okay, it will be interfaced with the internal bus of the processor. So whenever the microprocessor send or receive the control signals, so that means whenever the microprocessor sends the signals or it wants to receive the signal, that means to and from processor, so to and from operation of the microprocessor, control signals will be managed by this data bus buffer. So what is the purpose of this buffer unit? So this data bus buffer will be used to control or receive. So that means it will send the controls or it will receive the controls. So to or from operation to the microprocessor will be done by this data bus buffer. Okay, so by using this data bus buffer, the microprocessor either send or receives the control or status words to or from this 8259 unit. So that is the purpose of data bus. So this is a tri-stated bidirectional 8-bit buffer. Okay, clear? So next one is read and write logic. So this is a unit. So this unit is responsible for internal read and write operation. Internal read and write operations. So read and write logic. So this read and write logic unit is responsible for internal read and write operations. Okay, so whenever the system is performing, that means 8086 system. Okay, so whenever the system is performing either read operations or write operations, so that internal read and operations will be monitored, will be taken care by this read and write logic. So this read and write logic consists of certain pins. So this is read and write logic unit. So it consists of read pin, write pin, so A0 and CS. Okay, so these are the four things. These are the four pins that are connected to this read and write logic. So one is read, next one is write, next one is A0 and CS bar. So these are the commands that are used to instruct this read and write logic. So this read and write logic will have all these commands. Okay, so this read and write logic is responsible for internal read and write operations. So it is used to verify the internal read and write operations of the system. Okay, so it holds so what it do actually is it holds the initialization commands. Okay, so whenever we are providing the initialization commands to the processor through registers, so we will do it through registers. Okay, so the initialization process of the system will be done through registers. Okay, so whenever we are making sure of initialization process, so this unit holds the initialization of the command word. So initialization of command word to the registers. Okay, so it holds the initialization of the command word through the registers. So this command word registers inside this command word registers have different or various controls. Okay, so various controls will be present within this command word registers. So in this command word registers there are different controls. So based on the controls, any of these operations will be activated and any of the operations will be performed. Okay, so either read operation, write operation, or A0 or CS operation. So this is the read and write logic operation. So any of this read and write logic operations will be performed by this control word registers. Okay,
So the control word registers will hold, so this read and write logic unit holds the initialization of this control word registers through which any of these pins will be activated. So basically this read, write, A0 and CS pins are used for read. So this is used for reading the data. So this is used for writing the data. After the microprocessor is done with the operation, so this write pin is used to write the perform write operations. So CS, it is a low signal. So when CS bar is equals to 0, so this is chip select. So this is chip select. So when this CS bar is active low state, okay, so when it is in active low state, so that indicates that there is communication between 8259 and 8086 microprocessor. The communication, whether the communication is present in between these this PIC controller and the microprocessor, so that will be indicated by this chip select pin of read and write logic. So when this chip select pin is active low, so CS bar is equals to 0, that is CS is equals to 1, that means chip has got selected. So CS is active high, so CS bar is low, so that implies CS is active high, that means the chip is already selected. So that means there is communication between these two devices. So 8259 PIC and 8086 microprocessor, there exists a communication. So active low logic on this chip select pin shows that there is a communication in between, the communication has established in between this 8259 controller and 8086 microprocessor unit. Okay, so this is the read and write logic units, and these are the pins that are connected to this read and write logic unit. So comparator, so cascaded buffer or a comparator. So if you see, you all know that we all know that so cascading is nothing but combining. Okay, cascading is nothing but just combining the devices or combining the things. So cascading buffer or comparator. So I have already explained you about the cascading of 8259 units. Okay, so 8259 units can be cascaded in order to handle n number of interrupts at a single time. So so I have already explained that. So cascading of this multiple 8259 results in handling number of interrupts at a time. So this can be expanded up to 64 size. So that means 8259s can be connected in order to get this size. So that means we can cascade this 8259 units. So 8259 PICs can be cascaded. That's what we have already discussed. So this cascading of this 8259 will handle the number of interrupts at a time, so which can be extendable up to 64. Since this unit allows the comparison of IDs of different 8259. So we are now cascading different 8259s, and each 8259 will have a ID, so which is considered as system base address. Okay, system base address. So each 8259 will have an ID, so which we call as system base address. So this unit allows the comparison of different IDs of these 8259s that are cascaded and which are cascaded together, and it permits the operation of the system in two different modes. So it will perform the it will accepts the operation, it gives the permission of operation to this 8259 units, so which having different IDs. So it will verify the IDs and it will permits the operation. So it will permit the operation in two modes. Okay, so one is master mode and another one is slave mode. So in two types of operations, two types of
modes. In two modes, the system will permit the operation of the system. So one is master mode and another one is slave mode. So in the master mode of operation, this cascaded buffer or comparator circuit acts as a comparator. So in the master mode, it acts as a comparator. So it in master modes, it acts as a comparator, whereas in slave mode, it acts as a buffer. Okay, so here we are combining a buffer circuit and a comparator circuit. This will verifies the IDs of different cascaded PIC units, and it will permit the operation of the system. So here the operation of the system will be in two modes. So one is master mode and another one is slave mode. Under this master mode of operation, this unit will act as a cascaded comparator. Okay, so this will be acts as a comparator. So under the slave mode of operation, whenever the system is operating under slave mode, so that is then at that point of time, this will be acts as a buffer. So what is master mode and what is slave mode? So here we are connecting number of 8259. So that's it or not? So here we are connecting number of 8259 devices. So out of these all 8259 devices, one will be connected to a microprocessor unit. So the unit which is connected to the microprocessor unit directly will act as a master PIC. Okay, so this unit, this 8259 unit, which is directly connected to the microprocessor, is called as the master unit, and the remaining units which are cascaded with this 8259 are called as slave units. So that means whenever this unit is in active state and it is transferring the interrupts to the microprocessor unit, that mode is called as master mode, and this mode it acts as a comparator. Okay, and at this mode it acts as a comparator. When these 8259s receive some interrupts and these are transferring the interrupts to this 8259, so then it is called as slave mode of operation, and at that mode it acts as a buffer network. Clear? So clear about this cascaded అర్థమైందా?
Yes, ma'am.
Yes,
Yeah.
madam.
So next you have a control logic unit. So this control logic unit is now called as heart of the PIC architecture. So this is the main part of your architecture. So this control logic unit is called as heart of your PIC architecture. So what it do? It controls everything. So whatever the units that are present in your architecture of 8259, so everything will be connected to this control logic, and it will monitor, it will control the overall operation of 8259. So every device operation will be controlled by this control logic. So without this control logic, సో ఎవరికి నచ్చిన పని వాళ్ళు చేస్తారు. ఇప్పుడు ఒక సిఆర్ ఉండి మిమ్మల్ని మానిటర్ చేస్తే యూ విల్ బిహేవ్ సమ్ లైక్. సో ఎవరు ఒక టీచర్ ఉంటే యూ విల్ బిహేవ్ సమ్ లైక్, ఒక ప్రిన్సిపల్ ఉంటే యూ విల్ బిహేవ్ సమ్ లైక్. ఎవరు లేకపోతే మీకు నచ్చింది మీరు చేస్తారు. సేమ్ యాజ్ ఇట్ ఈస్ ఈ కంట్రోల్ లాజిక్ కూడా. సో ఇట్ ఈస్ కాల్డ్ యాజ్ ద హార్ట్ ఆఫ్ యువర్ పిఐసి. వెన్ ఎవర్ ఏ కంట్రోల్ లాజిక్ ఫెయిల్స్ డూయింగ్ ఇట్స్ ఆపరేషన్, everything behaves as it like. Okay, so this is the main part of your 8259 architecture. So it controls the overall unit operation. So every unit operation will be controlled by this control logic unit. So it controls the overall operation of the system by sending INTR signal to the processor. So these will be connected to the processor, but on the approval of this control logic only. So the INTR, so the interrupt signal will be transferred to the microprocessor. Okay, so whenever interrupt request is produced by a particular device, so it has to accept the device, it has to accept the request. So after accepting the request by the control logic of the
PIC controller, so it will get transferred to the microprocessor unit. So again, after when the system done with addressing the interrupt, so it will receives an interrupt acknowledgement. So whenever it also receives interrupt acknowledgement signal, so whenever the interrupt is processed by the processor, okay. So interrupt is done by the processor. So in ఇక్కడ ఒక ఇంటరప్ట్ రిక్వెస్ట్ వచ్చింది అండ్ ద కంట్రోల్ లాజిక్ హ్యాస్ accepted that interrupt request. So after accepting that interrupt request, it will send the interrupt to the microprocessor through INTR pin. So after the microprocessor addressing this interrupt, so that means microprocessor is working on the interrupt and it has executed the interrupt. So then the address has to store in interrupt service routine. So whenever the device which provides the interrupt, suppose ఒక input device వల్ల మనకి ఇక్కడ interrupt వచ్చింది అనుకోండి, so that input device, if it demands for the interrupt service routine, so if it demands for the address of the interrupt service routine, that means address of the interrupt handled, address of the interrupt handled by the processor, so then it demands the interrupt acknowledgement from the processor. So it will receive interrupt acknowledgement from the processor about this ISR, okay. So it receives the interrupt acknowledgement by the processor that the interrupt has been processed, and this control logic is responsible for sending the data address of the desired interrupt service routine through the data bus. So it uses the data bus and it will transfer the interrupt service routine of the interrupt handled, okay. So this is the main part of the PIC controller. So this is as it is doing the every operation, and it is controlling the operation of every device inside the controller architecture. So it is called as heart of PIC, okay. కంట్రోల్ లాజిక్ అర్థమైందా?
Yes, ma'am.
So next one you have in service register, interrupt request register and priority resolver. So for about these three we will discuss in the next class. Sorry, you have time, right? So interrupt service register. So continue చేస్తున్నాను. Actually I thought the time is up, but ఇంకా 15 minutes ఉంది, so we will continue. So next one you are having is in service register. So in service register, so what is meant by in service register? So this unit, so this register unit stores the interrupts which are being currently executed. So there are number of interrupts to the unit, right? So the unit will receive number of interrupts. So all those interrupts will not be sent to the microprocessor. The interrupts will be sent to the microprocessor one after the other. So suppose if the unit has 8 interrupts, so it has sent already microprocessor has addressed 3 interrupts, so it has sent the 4th interrupt to the microprocessor. So the present executing instruction is your 4th interrupt. So it will holds the address of this 4th interrupt, okay. So it will stores the information of this 4th interrupt, that means which is currently executing by the microprocessor. So what is the interrupt that is presently executing by the microprocessor unit? So it will store the data of that particular interrupt. So the in service means whatever which is presenting at that particular point of time, whatever the interrupt that is executing at that particular point of time, so that data will be kept by this in service register. So in service register, so this is a unit used to store the interrupts which are currently being executed by the processor. So the priority resolver, after resolving the after prioritizing the interrupts, it will assign the numbers to the interrupts 1, 2, 3, 4. So likewise it will assign the interrupts. So the interrupts will be transferred to the microprocessor one after another. So whatever the present instruction that is transferred to the microprocessor, so that information will be present in this in service register. So after getting an interrupt word command by the processor, so it will gives the interrupt to the microprocessor and it will be in reset state. So it will transfers the data and it will be in reset state. So that means it will not have any command now. So after when the priority resolver prioritize another interrupt and it will send the interrupt to this in-service register. So it will again send the data to the control logic, which further sends to a microprocessor. It is a sequential process, okay? So with which further sends to the microprocessor, so that it will hold. So whatever the interrupt that has been sent to the microprocessor, that will be hold in this in service register. So as the processor holds the ability directly, so this in service register is used. So the processor holds the ability to directly read the status of this in service register, okay? So the data will be present in this in service register, since this processor can read this directly. So whatever the data in the in service register, that can be read by this processor directly, so it will hold the data. So next you have priority resolver. So I have already explained you about priority resolver. So this unit decides the priority of the interrupt. So that means this present in IRR. So every interrupt request will be come to IRR. So let me first explain about IRR. So this is interrupt request register. Okay. So what is IRR? It is an interrupt request register. Interrupt request register. Okay, interrupt request register. So this interrupt request register stores the interrupt request generated by every peripheral connected to the microprocessor. So suppose if there are 8 interrupts generated by different peripherals connected to the processor. So here we are connecting different peripherals. So if there are 8 interrupts generated by all these peripherals to the microprocessor unit, so all those 8 interrupts will be kept in this interrupt request register. So this unit stores the interrupt request generated by all the peripherals connected to the device. Okay. So we already know that 8259 has 8 interrupts, right? So these 8 interrupt pins IR0 to IR7. So these are the 8 interrupt pins that are present in IRR register. So this 8 interrupt pin holds 8 interrupts. Okay, so 8 interrupts from various peripherals. So ఎక్కడి నుంచి మనకి interrupt వచ్చినా కానీ సో interrupt request register లోని ఆ interrupt స్టోర్ అవుతుంది. సో it will keep all the interrupt requested generated by all the peripherals or all the external devices. So after it keeps keeping all the interrupts, this priority resolver will get activated. So what this priority resolver do? So this unit will now verify all the interrupt requests present in this IRR and Hello, am I audible?
Yes, ma'am.
Sorry for the inconvenience. I was out of the meeting actually. So you can see the screen, right? Just a moment. You can see the screen, right?
Yes, ma'am.
Yeah. So this priority resolver. So this priority resolver unit decides among all these interrupts which interrupt should be serviced by the processor first. So which I have to send which interrupt first to this microprocessor. So that will be decided by this priority resolver. So whenever we are having certain number of interrupts over this interrupt request register, so it will prioritize the which interrupt has to be first serviced by the microprocessor unit. So it will prioritize the interrupts. So that means it will sets the highest priority and least priority among the interrupts, and it will transfers the interrupts based on the priority. Suppose at the time of servicing the interrupts, another incoming interrupt is there. Okay. So suppose the microprocessor is servicing an interrupt and it has already set the priority to these particular interrupts present in IRR. And now after setting the priority and after sending an interrupt to the microprocessor, when there is an incoming request for the interrupt, when there is another incoming interrupt request, so then then that particular interrupt request will be ignored as it has already sent an interrupt based on the priority finalized. Okay, so it has already finalized the priority among the available interrupts. Okay, here there are number of available interrupts, and among those interrupts the priority has already set and a particular interrupt has been already sent to the microprocessor. So when at the time there is another interrupt request on this IRR, so that particular interrupt request will be ignored. Okay, so as one which being currently executed, so here it has already executing a particular interrupt, right? So the microprocessor is already executing a particular interrupt, so the one will be ignored for the current executing instruction, and the interrupt priority is again set within the interrupts again. So it will set the priority interrupts again within the available interrupts. Simply it means only the interrupt holding highest priority will be forwarded to the microprocessor. Okay, so the 8259 will forward the highest priority interrupt prioritized by this priority resolver will be sent to the microprocessor unit for execution. Clear?
Yes, ma'am.
So your last one is interrupt mask register. So this interrupt mask register will block masking bits. Okay, so we have different types of interrupts, right? Out of which one is maskable and another one is non-maskable. So maskable is nothing but which can be neglected. So these maskable interrupts are need not to be addressed by the processor. 8086 will not address these maskable interrupts. So these can be neglected. So these are having very least priority interrupts. So these they will not be addressed by this microprocessor unit. So next one is something called non-maskable interrupts. So whatever the interrupt priority has been setting by this interrupt priority resolver. So those priorities will be set only to this non-maskable interrupts. Okay, so however the maskable bits will be sent to this interrupt mask register, and here they will be nullified. So this register block holds the masking bit of the interrupts which are to be masked. So through this masking device, through this interrupt mask register, so operation command word will be sent to the processor. So it will send an operation command word to the processor saying that we have an interrupt and it can be maskable. So that means this maskable interrupts will not be addressed by the microprocessor unit. So 8086 will only handle
non-maskable interrupts. So whatever the maskable bits are present or coming to this particular registers, so those bits will be masked by this interrupt mask register. So this interrupt mask register will be used to mask the interrupts that are provided by the different peripherals. Okay, clear? So these are the units that are present in your architecture of 8259. So these are the different units. So one is data bus buffer, so which is connected to the internal bus in order to transfer the data between this PIC controller and the microprocessor unit. So read and write operations will be, internal system operations will be monitored by this read and write logic circuit. So cascaded buffer, so based on master slave operation of the cascaded 8259 units, so it will be operated as buffer in the slave mode of operation, and it will be operated as comparator in master mode of operation. So next one is control logic. So it will controls everything. So every unit operation will be controlled by this control logic unit. So next you have in service register. So whatever the interrupt is handling by this microprocessor unit, that data will be present in this in service register. So next you have interrupt request register. So how many interrupts? So this 8259 is capable of holding 8 interrupts. So it has 8 interrupt lines, input interrupt lines. So whenever an external peripheral is requesting for an interrupt, so all those interrupts will be kept at this IRR. So next you have priority resolver. So among the available interrupts in the IRR, so which has the highest priority? So that will be set by this priority resolver, and it will send the highest priority interrupt to get executed. So last one is interrupt mask register. So interrupt mask register is nothing but we have two categories of interrupts which can be neglected and which has to be compulsorily addressed by the processor. So which are called as maskable and non-maskable. So these are non-maskable interrupts are compulsory addressed by the processor. So these maskable interrupts can be neglected. So those interrupt bits will be sent to these registers and they will be nullified. So this is the internal architecture of 8259 and how all these combinedly work in order to transfer the interrupts to the microprocessor. So the purpose of this microprocessor 8259 PIC is to transfer the interrupts to the microprocessor. It will not address any interrupt. It will not serve any interrupt. It will just simply transfer the interrupt to the microprocessor unit. So this is all about 8259 programmable interrupt controller and how it is used to transfer the interrupts. Clear?
Yes, ma'am.
అమ్మా అర్థమైందా ఇక్కడ వరకు? సో ఈ రోజు క్లాస్ లో ఏమైనా డౌట్స్ ఉన్నాయా? So do you have any doubts in today's class? No, right? So if you have any doubts, if you come up with any doubts, get to me through a phone call or a WhatsApp. So I will explain. So next thing is software or hardware interrupt applications, your next concept. So that we will see in the next class. Okay? Okay. Thank you.
Thank you, madam.